In this lesson, we begin our work with the irrational number e. The number e is one of the most famous numbers in mathematics. As your mathematical studies progress from advanced algebra all the way through calculus, you're going to discover that the role of e in mathematics is equal in importance to that of the number pi. Now, e is equivalent to approximately 2.718288183, and that decimal continues on forever. Remember that an irrational number is a number that cannot be written as a fraction or a ratio. This number was named after the 18th century Swiss mathematician Leonhard Euler. Now, you guys know that pi is the ratio between the circumference and the diameter shared by all circles. E is the base rate of growth shared by all continually growing processes. In order to help us see the importance of E, let's go ahead and consider the following example. Let's say you walk into a local bank to open up a savings account with $1,000. The bank offers you two options. In option one, the bank offers to pay you 100% interest once in the year. In option two, the bank offers to pay you interest twice in the year. That is 50% interest for the first 6 months and then another 50% interest in the last 6 months. So my question to you is, which is the better option and why? Before I give you the answer, take a few minutes to pause this video and think about which option is the best option. All right, hopefully you took some time to consider both options and came up with a conclusion. Let's go ahead and look at option number one to start. So in option number one, we were given $1,000 and we get 100% interest only once in the year. Well, 100% interest on $1,000 is an additional $1,000. So at the end of the year for option one, I have $2,000. Let's go ahead and look at now option two to see which one's better. So in option two, we started with $1,000. And after 6 months, we get 50% interest. Well, 50% interest on $1,000 is an extra $500. So I have $1,000 plus $500, which is going to be $1,500 after the first 6 months. Then after the additional last 6 months in the year, we get another 50% on that interest. Well, that new interest is going to be off of $1,500. So $1,500 plus 50% interest. Well, 50% of 1,500 is $750. So if I add those up, I get $2,250. So between option one and two, I'll definitely take option number two, and I'll get an extra $250 by the end of the year. Now, how does this relate to the importance of E? Well, looking back at this example, you saw that option two gives us more money because we reinvested halfway through it. So now the question becomes, would we get even more money if we were able to reinvest multiple times throughout the year? Maybe every month, maybe every day. And that's how compounded interest comes into play in terms of finances. Compounded interest is interest upon interest upon interest. The more times we can compile interest over the year, you'll see the more money we make. Well, eventually this is going to plateau or reach a peak exponentially. And that exponential value is going to reach at a value of E, 2.7182813. Now let's go ahead and look at the graph of y equals e to the x. A graph to the right has been drawn in for you in blue for this function. You can see that it passes the horizontal line test, which tells us that the graph of y equals e to the x is a one-to-one function. And based on us knowing that it's a one-to-one function, we know that the inverse has to also be a function. Well, what is the inverse of y equals e to the x? Well, if I was to flip-flop the coordinates x and y, you can see I have this graph in red. That graph in red is called y equals ln of x. If you think back to the relationship between exponential functions and logarithms, we know that logarithms and exponentials are inverses of each other. The only difference is now that my base is e. So y equals log base e of x is the inverse of y equals e to the x. And we refer to log base e of x as natural log of x. So I made a note here that logarithms with base e are referred to as natural logarithms, and they use the symbol ln to represent a natural log. So here I wrote log base e of 15 is equivalent to ln of 15, or natural log of 15. And if I type in ln of 15 on my calculator, there's a natural log button. It says ln, select that and type in 15, and you get approximately 2.70. So what I want you to note here is that e and natural log, or ln, are inverses of each other. All right, and if you remember in mathematics, inverses undo each other. Just like adding 2 and subtracting 2 cancel out, multiplying by 2, dividing by 2 cancel out, e and ln also cancel out. Now in the next set of examples, it's asking us to convert to exponential form. For the first one, I have natural log of x equals 1.25. Well, I know that natural log of x is really log base e of x, which equals 1.25. Now I need to convert this to exponential form, so I can go ahead and convert this using our canoe trick. So e to the 1.25 has to equal x, and that would be my answer in exponential form. In the next example, we have natural log of 25 equals x, so I can rewrite natural log again as log base e of 25 equals x, and if I apply my canoe trick, I have e to the x equals 25. And that would be my equation in exponential form. Now in the next two examples, they're asking us to convert from exponential form back to logarithmic form. So to do that, e to the x equals 23. I know that I can rewrite this in log form. Log base e of my answer 23 equals my exponent x. In the second one, e to the fourth equals x. I can rewrite this as log base e of my answer x equals my exponent 4. Remember, logs find exponents. So one important thing to note, that since ln, or natural log, and e are inverses of each other, if they are multiplied together, like you see here, natural log times e to the x, the ln and e are going to cancel out to simply x. Remember, inverses undo the operations. Now let's consider an application question. Suppose you deposit $700 into an account paying 3% interest compounding continuously. After how many years will the balance be at $1,000? They give us this formula to help solve this application question of A equals P times E raised to the RT. Let's go ahead and start by establishing what each of these variables represent. A is going to represent our end amount. P is going to represent our principal, which is our beginning amount. E is our base. R is our rate, and that rate needs to be in a decimal. And T is our time. So let's go ahead and plug in what's given to us. We know that our end amount needs to be $1,000. Our initial amount was $700 that we deposited. Our base is E. Our rate is 3%, so 3% as a decimal, you can just take that number 3 and divide it by 100, and we get 0.03. And we don't know our t, which is our time. That's what they're asking us to find, how many years. So now we have this equation that's in exponential form. 1,000 equals 700 times e raised to the 0.03t. So to solve this, first I want to get rid of 700 by dividing. And I get 10 over 7 equals e to the 0.03t. Now, in order to solve for t, we have to get rid of base e. Now, remember, e and ln are inverses of each other. So if I can multiply both sides by ln, the ln and e will cancel. So now I have 0.03t equals ln of 10 over 7. And so now to get t by itself, I can take ln of 10 over 7 and divide it by 0.03, and I get t to equal approximately 11.89 years, in which our $700 deposit will turn into $1,000. Now at this point on this last slide, I would urge you to pause this video and go ahead and try these 5 practice problems dealing with base E and natural logs. So hopefully you had a chance to work on these 5 problems. Let's look at example A. We have 3e raised to the negative 2x plus 4 equals 10, and I need to solve for x. So first step, I'm going to subtract 4, and I get 3e to the negative 2x equals 6. Now I need to get rid of this 3 that's being multiplied in front, so I'm going to divide by 3. And now I get e to the negative 2x equals 2. And to get rid of e, I'm going to take the ln of both sides. Since ln and e are inverses, I get negative 2x equals ln of 2, and I can divide both sides by negative 2. And to solve for x, I get ln of 2 divided by negative 2, which gives me, let's see here, negative 0.35 if I approximate that decimal. Let's look at example B. 10 minus 3e to the x minus 1 equals 2. I'm going to start by subtracting 10. Negative 3e to the x minus 1 equals negative 8. Divide both sides by negative 3. And I get e to the x minus 1 equals 8/3. Be careful, a negative over a negative is a positive. Now to get rid of e, we'll take the ln of both sides. Ln and e cancel. I get x minus 1 equals ln of 8/3. And then we can add 1. And I get x to equal approximately 1.98. In letter C, I have ln of 2x minus 1 equals 7. So I need to get rid of ln by taking the e of both sides. So e and ln cancel, and I get 2x minus 1 equals e to the 7th. Now I need to solve for x, so I'm going to add 1 to both sides. And I get 2x equals e to the 7th plus 1. And then I need to divide both sides by 2. And I get x to equal approximately e to the 7th plus 1 divided by 2 is 548.82. In letter D, I have ln of x plus ln of 2x equals 8. Now to do this problem, it's going to be helpful to recall those properties of logarithms. Remember that ln is a natural log, which is a type of logarithm. So our properties for expanding and condensing using the product rule, the quotient rule, and the power rule also are going to extend to natural logarithms. So ln of x plus ln of 2x, I can condense this to one single natural logarithm by, since this is addition, we know we can multiply these two natural logarithms together. So I have ln of 2x squared equals 8. Now I can take the e of both sides, and I get 2x squared equals e to the 8, divide by 2, and I get x squared equals e to the 8th over 2. And now I need to solve by taking the square root of both sides. And I get x equals plus or minus 38.61 if I type that in on my calculator. When I'm typing this in, be careful to type in e raised to the power of 8, hit enter, divide by 2, hit enter, and then take the square root and hit enter, and you should get your 38.61. Now, before I circle my answer, because I had two answers of plus or minus, you have to recall that natural logarithms, or even logarithms in nature, are always going to have answers that are positive, right? We take any base to some power, whether that power is a fraction, a negative, a positive, any real number, it's always going to give us a positive answer out. So the only answer we're going to consider here is the positive 38.61. And now in our last example, letter E, we have ln of x minus 2 plus ln of x equals ln of 3. So to solve this, I'm going to go ahead and condense the left side. So it's going to be ln of x minus 2 times x equals ln of 3. So I have ln of, and I got to distribute this x now. So it's ln of x squared minus 2x equals ln of 3. And to get rid of ln on both sides, I'm going to take the e to both sides. So I have x squared minus 2x equals 3. Bring the 3 over, and we have a quadratic equation now that I can factor. So x times x is x squared. What multiplies to negative 3 and adds to negative 2 is negative 3 and positive 1. If I set my factors equal to 0, I get x equals 3, x equals negative 1. Again, logarithms can only have answers that are positive, so I'm going to only count x equals 3. X equals negative 1 would be considered an extraneous solution for this problem.